we need to pick back up where we left off yesterday with hyperbolas. We spent yesterday going through hyperbolas centered at 0, 0, yes? Okay, so you've seen the charts, you kind of know what you're looking at. Today we're going to look at our hyperbolas that are centered at HK. Now, very similar to what you saw yesterday, also very similar to our ellipse charts. We still have the left column, right column. You'll notice it's still x squared over a squared is first in the left column. Y squared over a squared is first in the second column. And they're hyperbolas, so there's a minus in the middle. Remember, when x comes first, and it's x squared over a squared, that means we're looking at a horizontal axis. And so my hyperbola is going to open left and right. Okay? That's when you have the x first. When we have the y first, we're looking at a vertical axis. Because remember, y's go vertical. And so you're going to have a hyperbola that opens up and down. Okay? Focal axis, foci, vertices, those all should seem familiar with what we've already done in relation to ellipses and our hyperbolas yesterday. Remember I introduced the transverse and conjugate axes instead of major and minor axis like what we had with ellipse. Excuse me, we have transverse and conjugate. Now, what I did yesterday is if it's a semi-transverse axis is A, remember the transverse axis is going to be equal to 2A. If the semi-conjugate axis is B, then that means the conjugate axis is equal to 2B. We still have the same Pythagorean relation as yesterday, and that is with all hyperbolas, it's always c squared equals a squared plus b squared. And then one of the things that also changes with the HK, asymptotes. On asymptotes, when it was centered at 0, 0, it's just plus or minus b over a times x, and plus or minus a over b times x. Now we've thrown in the x minus h and the plus k. Okay, so it's still filling in, though, your a, b, h, and k. Okay, I'm going to jump right into example 3. You guys have kind of seen these charts. These charts have kind of been familiar with what we have in relation to ellipses. So, example 3. It asks us to find the standard form of the equation for the hyperbola whose transverse axis has endpoints -2, -1, and 8, -1, and whose conjugate axis has length 8. Thoughts on where we can begin? What do we know? What can we figure out?
K.
What about K?
Well, let me look at it real quick.
I agree that I know K.
Yeah, because of it's both of them wide.
Okay. So on our transverse axis endpoints, what he's looking at is both of the y's are the same, yes? And if both of the y's are the same, that is giving us K. Now, let me talk transverse axis endpoints. What are the ends of the transverse axis called? What's the vocab word there? These are the vertices. Okay, so when we talk about the transverse axis endpoints, that is fancy speak for these are the vertices they're giving us. Okay, and so with that in mind, if you look at vertices, there's one of the columns where the K value is consistent. So I could agree with that. Okay. What else you want to talk about?
So with that, can we find A?
We can find A. How can we find A?
The distance between those 2 points.
Okay. Yeah. So transverse axis. On the chart, it says semi-transverse axis is A, right? So then I always change that to the transverse axis is 2A. Well, how long is my transverse axis going to be? What is the distance from -2, -1 to 8, -1? 10. A distance between negative 2 and 8 would be a distance of 10. Now, I'm not saying you'd have to, but for some of you, a picture might be helpful here to see that visual. And so, if that's the case, there's my point at negative 2, negative 1. And there's my point at 8, negative 1, right? With that in mind, those are the ends of the transverse axis, right? So, from negative 2 to 8 is a distance of 10. So the transverse axis, 2a equals 10, and thus a is 5. Okay. What else do you want to talk about?
Conjugate axis is 8.
Conjugate axis has length 8, right? So transverse axis, we had endpoints. They were 10 apart. Conjugate axis has length 8. So we know conjugate axis, the entire conjugate axis is 2b. If it has a length of 8, then we know that b is 4. Okay? Well, we know A and B. What else do I still need to know? H and K? Or we could argue we already know K. But what would be an easy way to find H and K at this point? What do H and K represent? Well, H and K are my center, right? If H and K are my center, what do you know? So yeah, if these are the vertices or the transverse axis endpoints, either way, even if you didn't figure them out as vertices, they're the ends of one of my axes, right? Where's the center going to be? Smack dab in the middle. So if this was a length of 10, how far do I need to count in? We're counting in 5, yes? So it's the idea here, and that's also your A value that counts in 5. So what is that point that we just found? You have a center at 3 is in the middle, and it's still going to be on a level of -1, so 3, -1. And that means 3 and -1 are my H and K. Okay. I know A, I know B, I know H, I know K. The only thing we have not officially talked about is which equation am I using. Is this left column where X comes first, or right column where Y comes first? Which one? The left column? How do we know that? Okay, the vertices thing. A couple of things. My transverse axis is horizontal, right? That's your major axis. When that's horizontal, that means X is going to come first. The fact that these ended up being my K's. Okay, if you look in your left column, this is going to be H plus or minus A, is what that's going to be. Okay, so we are working in the left column. So we're going to use X minus H squared over A squared minus Y minus K squared over b squared equals 1. Nobody ever told me to find c here. Do we need to find c? No, because we don't have to do anything with our foci. Okay, you can find c if you want, but it's not required, so I'm not going to do it. Okay. What do we got here? X minus 3 quantity squared over a squared, 5 squared, which is 25, minus y minus k. So y plus 1 quantity squared over b squared, 4 squared, which is 16, and don't forget, equals 1. Okay. Questions on that one that I need to clear up? Is this seemingly similar to ellipses to an extent that it's helping? I know ellipses were a little foggy at the time. It took us some practice, but hopefully this is kind of clearing things up. That's my hope. Okay. Example 4. It asks us to find the center, the vertices, the foci of this hyperbola, and for practice sake, we're also going to sketch it. Okay? This is a better one to sketch than the one on the next page anyway. So we're going to sketch it when we get done with it. Thoughts here?
Center is negative 2 and 5.
Center is negative 2, 5. You guys agree with that? My center, as always, is HK. And here's the deal. We haven't even talked about which column that is, and it doesn't matter because H always comes from your X. So if this is X plus 2, then we're going to use negative 2. K always comes from your Y. So if this is Y minus 5, then we're going to use positive 5. So my center is indeed negative 2, 5. Okay, what else? Okay, can we talk A and B? Is this left column or right column? This is left column, yes, because why? X is first. It's a subtraction sign, X is first. So for the record, this is X minus H squared over A squared minus Y minus K squared over B squared equals 1. So we are going to have to talk about A and B, or at least A. No, A and B. What is A? A is 3, because A squared is 9, right? What's B? B is 7, because B squared is 49. I mentioned this yesterday, but I'm going to remind you today. It's a hyperbola. A does not have to be bigger. Okay, that's an ellipse only thing. This is the positive variable comes first. What else do I need to find besides A and B? Eventually, I see foci in my upcoming list of things to find, so I'm going to have to find C. You guys know what to do here, yes? C squared equals A squared plus B squared. So C squared equals 3 squared plus 7 squared, 9 plus 49. C squared is 58, so C is I'm going with the square root of 58. However, what'd you say, 7.7? 7.6? Okay. And If I need that, I'll use it, but for the specifics of C, I'll leave it as exact, okay? Okay, so we have found center. What do we still need to find? Vertices and foci. What do we know about vertices? Vertices is going to be
H plus or minus A, comma
H plus or minus A, comma K. Fill in your information. So what H is -2 plus or minus A, which is 3, comma K, which is 5. Do I get to leave my answer like this? No, that's still math that's doable, right? Clean it up. Don't leave it as the plus or minus when I can add those. So -2 plus 3 is going to be 1, comma 5. -2 minus 3, -5, comma 5. Do the math when you can, guys, right? That's vertices. And the other thing we have to talk about is foci. Foci, have you learned? It's pretty much the same thing as vertices, except instead of A, we're going to use C. So H plus or minus C, comma K, -2 plus or minus square root of 58, comma 5. And what about these? Do I go farther on the foci? Not this time, right? If it's something there where it's not a perfect square, just go ahead and leave it as -2 plus or minus the square root of 58, comma 5. If we needed those exact value or the decimal values to be able to help us graph this, then we could find them for that purpose. But in terms of stating what your foci are, we're going to leave them like that. Okay, officially that's all that 4 asks us to do. However, I want to make sure we have a good understanding of how to graph these. Okay, so we're going to use this one as a graphing example. So I kind of left space over here. When you set this up, you really need quadrant, 2, the upper left quadrant mostly available. As you set this up, I think I need to be able to go down 2 tick marks. I need to be able to go right 1 tick mark. I need to be able to go 5 left, and you need to be able to go 12 up. Okay? Those are your bare minimums at least. You have to be able to go 2 down, 1 right, 5 left, and 12 up. Okay. I would start by graphing your center. Not that the center is a point that we really are going to, it's not physically part of the graph, but it's our centering point to get us started. And our center was at -2, 5. So my center point there is -2, 5. Where can we go from there?
Vertices.
Okay, vertices. How do you want to do the vertices? A, did we find the vertices? Yeah, they are at 1, 5. And they are at -5, 5. Now, we had found the vertices here. how else could we have plotted those vertices? What's the other connection? Besides the fact we had found those vertices, from the center out to a vertice, what is that value? That is A. Notice, what is A? A is 3. So if you go 3 left and 3 right, that is your A value. Okay. And I know I know my A value is going to go horizontal because it's under X. X's go left to right, so that means my A value goes horizontal. Now, what's B tell me to do? B is 7. That's going to tell me to go where? Up and down 7. Okay, and yes, I need that value to be able to officially graph this. It's going up and down because it's under the Y. So we're going to go up 7, which means you're going up there to 12, and down 7 puts you at -2. That is your B value that took you there. Okay, those are your B values, and it was a value of 7 in this case. Okay. Now, what do you remember from yesterday? Once you have your 4 points, your 2 A's and your 2 B's, what did we do? We draw a box, right? So I'm drawing a box using those 2 A's and those 2 B's. Okay, so my box goes through those 2 A points and those 2 B points. What is the point of this box? This is what creates my asymptotes. Yes, I could have used that formula, I'm trying to think which one it is, the plus or minus B over A times X minus H plus K. I would much rather do this, okay? So now asymptotes, if you recall, asymptotes have to go through your center, and they go through the diagonal corners of the boxes, or of the box. So I've got one asymptote. Whoops. How do I get that off of there? There we go. One asymptote goes through the center and those 2 diagonals. And one that goes like that. Now, final question. Hyperbolas. Like this, up and down, or like this, left and right? Left and right. These were under the X's, okay? They go off of your vertices, which are out left and right, but it's under your X's. X's go left and right. So these hyperbolas are going off these vertices here, and what it is these hyperbolas are going to be very wide here because my asymptotes are very wide in this direction. So very wide hyperbolas. If we were going up and down, they'd be much more narrow in this particular case. Okay? Knowing how to draw them is important, knowing how all the pieces go together. Questions before we turn the page? Okay, we'll turn the page when you're ready. And, okay, eccentricity is back. We talked about with eccentricity with ellipses, and it talked about how elongated the ellipse was, right? And if you recall, it was a number between 0 and 1. We're talking about it in relation to a hyperbola. Now, good news, formula is still the same, okay? Eccentricity is equal to C over A. This square root just tells us how C can be found, but you guys know how to find C. So it's C over A. Eccentricity of a hyperbola is always bigger than 1. Okay, it's always bigger than 1. It's describing how wide the parabola, the hyperbola is. Like that last one we talked about would have, had a higher eccentricity because it was a very wide hyperbola. And for comparison's sake, the eccentricity of a parabola is what is exactly 1. Okay, so that parabola falls right there in the middle. Now, example 5. We're being asked to graph the following hyperbolas, stating their vertices, foci, asymptotes, eccentricity. I'll be honest. We're not going to necessarily graph this one, but my job that we do need to make sure we do is get to the point where we can find vertices, foci, asymptotes, and eccentricity. And I say we're not going to necessarily graph this one just because we're probably going to run out of time, but maybe not. We'll see. What's the hard part about this problem? They didn't give us the nice form, did they? We've got to get the nice form. Okay, so this is something you struggled with ellipses because my lesson kind of got cut off. We're back. Learn it this time, okay? So at the time it was group the what? Group the x's, group the y's, constants on the right. It's still the same idea. The only thing I'm going to say is I want my positive squared first, then the minus squared, and then the constant. As in, sometimes it'll be x's that go first, sometimes it'll be y's that go first. Am I making sense there? So in this case, what am I going to put first? I have a positive y squared, so I'm going to group my y terms first, and then my x terms because I have a negative x squared term. So I'm going to group this as y squared plus 6y. Then I'm going to group my x's, minus 3x squared plus 6x, and then 18's already on the right side, so I don't have to worry about moving anything over. We need to prepare ourselves to complete the square, yes? I didn't really say it. I kind of left gaps a little bit. Didn't really have to have gaps that line because we'll need them on the next line. My y's are already ready, aren't they? So I'm just going to recopy my y's for the moment. Y squared plus 6y. I'm going to leave a gap. We'll come back and complete the square for y's in a moment. Are my x's ready? What has to be true to complete the square? It has to be a 1x squared or 1y squared, right? We have 1y squared. Do I have 1x squared? No. What do we need to factor off of that x squared? The negative 3. So I'm going to factor off the negative 3 there. So I'm leaving a gap, negative 3. When you factor that off, we're going to have x squared. What is 6x when I factor away the negative 3? Minus 2x. Leave a gap into the parentheses, and then equals 18. Okay, let's go back and do some complete the square business. Okay, how do we complete the square? We're doing what? B over 2, quantity squared. What's B for my y's? 6. So 6 divided by 2, quantity squared. 6 divided by 2 is 3. 3 squared is 9. What am I doing with that 9? We're going to add 9 on the left. If we add 9 on the left, we add 9 on the right. And then repeat the process with the x's. What is my b value for x? Negative 2. So negative 2 divided by 2, quantity squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. I'm going to add 1 on the left inside those parentheses. If I add 1 on the left inside those parentheses, What do I do on the right? You add 1 times negative 3. Why am I adding 1 times negative 3? This 1 is what? Multiplied by this negative 3 out here. So really we're subtracting 3 if you want to say that. I'm good with that too. Okay. Every time we complete the square, the whole point of completing the square is you are set to factor. Every time. Okay, so the y's. Square root of y squared is y. Square root of 9, 3. And we're going to need a plus 3 plus 3 plus 3 gives us plus 6, right? So say positive 3. Don't forget your squared that I almost forgot. Minus 3 stays out front. Now the square root of x squared is x. The square root of 1 is 1. This time, how is 1 and 1 equal negative 2? Needs to be a negative 1. So x minus 1 squared equals 18 plus 9 minus 3, which is 24. What's the next step? Yeah, to get this in our standard form, divide all 3 pieces by 24. And so now, y plus 3 squared over 24 minus, what about that 3 over 24? 1/8, right? So it's an 8 in the denominator. So x minus 1 squared over 8 equals 1. Okay. Now, before I head up to vertices, foci, asymptotes, and eccentricity, in order to do all of that, we need to know H, K, A, B, C. Let's start with H and K. What's H? Nope. H is 1. H always goes with what variable? X. Keep in mind, y comes first, yes? Which column are we looking at here? This is the right column, isn't it? Okay, so your H is always, this is always going to be the X minus H, so 1. What's K? Y minus K, so K is negative 3. Here's a trick to see if we're paying attention. What's A? Everyone's afraid now. What's A?
The 24 but square root.
Yeah. A squared is always first. Okay. So A is going to be the square root of 24. Are we good?
So do we have to simplify on those?
I'm getting there.
Okay,
I'm trying to make sure I'm not convinced everyone's with me. And this is where I need to hear the questions if you're not with me. Okay. A is the square root of 24. What is that simplified?
2 square root of 6.
Yeah, the square root of 24 is 4 times 6. And the square root of 4 is 2. So it's 2 square root of 6. Mine, I have some simplified pieces in here. you want to know how to simplify them. You want to be able to recognize those, okay? I'm not saying they necessarily have to be simplified, but on the flip side, it's a good time to practice it too, okay? What about B? What's B? B squared is the 8, so B is the square root of 8. 8 is 4 times 2, or in other words, 2 square root of 2. And we need to find C, yes? C squared equals A squared plus B squared. So that means C squared is 24 plus 8. So C squared is 32. Oops. So I'm going to bring it back over here. That C is the square root of 32. What about the square root of 32? What perfect square is in 32?
Or no, right? 4.
16.
Biggest is 16, because it's 16 times 2. I'm not going to argue with 4, but biggest is 16. So 16 times 2, or in other words, this becomes 4 square root of 2. Okay, I have HK, ABC. Do I have all the information to find everything else? Hopefully, yes. Okay, vertices. What's my formula for vertices?
H plus or minus A.
I think I'm going to reverse that. Which column are we in here? Y came first, yes? So we're in the right column. If we're in the right column, it's H, comma, K plus or minus A, yes? So then we're going to have 1, comma, negative 3, plus or minus 2 square root of 6. And of course, for those vertices, I'm going to say leave it like that, right? Part of the reason I'm not going to push us to graph this one when we just graphed the previous one, because we've already got not fun decimals here. What about foci? H, comma, K plus or minus C. So 1, comma, negative 3 plus or minus 4 square root of 2. Okay, here's a new one. Asymptotes. Now, it's a new one, but do we have a formula for it? Yeah, grab the formula. Remember, Y came first, so I'm in the right column. In the right column, never remember which is which. This is going to be the one where it's going to be plus or minus A over B times X minus H plus K. Now, in terms of A over B here, you're going to reduce whatever fraction you have there. So you can use the simplified versions, or you can use the original versions. They both are going to simplify pretty well. I don't even know if I wrote, yeah, I didn't necessarily even write it out. So if we say plus or minus, if I do A over B in the simplified, it's 2 square root of 6 divided by 2 square root of 2 times X minus 1 and then minus 3. I'm not going to leave it like that, though. What about this a over b. The 2's will cancel. What's the square root of 6 divided by the square root of 2? Square root of 3. So out front, this can just become y equals plus or minus the square root of 3 times x minus 1 minus 3. If you would have done square root of 24 divided by square root of 8, you also would have gotten the square root of 3. And one last thing we need to find, which is eccentricity. Formula is E equals C over A. What do we have? So when I look at C over A, I don't really want to have to worry about square root of 2 over square root of 6. So I'm going to go back and say, in this case, square root of 32 over square root of 24. That'll make the simplifying a little bit better. I reversed that, didn't I? No, I didn't. No, I'm good. 32 over 4. Or 32 over 24, what's that reduced to? 32 and 24 both divide by 8. And so this is square root of 4 over square root of 3. I'll be honest, my answer key says square root of 4/3. However, if you had happened to put 2 over the square root of 3, that is equivalent as well. Okay? Now, as you clean up, I don't think this class talked about it yesterday. Your homework on page 592. 2, 4, 6, 7 through 10, 24 to 42 even, 49 and 50. Omit number 34. Did we figure out that vocabulary word?
Leave out.
Skip number 34. Okay? That's what that is saying. Go through the homework. Do the homework for tomorrow. Bring back your questions.